Hello guys, welcome to EasyMathWithDami. Today we'll continue with the integration by parts using Tabular Method. In my previous video, I talked about this recursive integration using the classical method that we know to solving it, and then we arrived at this answer. So I'm going to encourage you that if you haven't seen it, you could just I'm going to attach the link to the description so you could just check it out. It's quite long, but it's interesting. Believe me, you're going to like it. So today we'll solve this problem using tabular method. How we have to do basically is that we should identify what our u is, and then identify what our dv is, and then we'll plot it in the table. So right, we'll just go straight into that. So our u is going to be e to the power ax, and then our dv it's going to be cos bx. So you might be wondering how was I able to identify these guys. So because we talked about Lahet, so I'll advise you to check that out as well. So I've made a video on that. So all we have to do is just to put all this in the table, and then we get our answer straight away. So let's just plot the table. So we have u so I'm going to do something like this. So then we have our dv. Yeah. So my u it's e to the power ax, and then my dv is what? Cos bx. And then we know what we're supposed to do, right? You differentiate the u and then integrate the dv, and that's it. So let's just go straight to the point. Let's take them one after the other. We'll differentiate first, and then we'll integrate the dv, and then we'll add sign to it, and then we'll take the necessary terms out. So differentiating the u first, we're gonna have this, right? So differentiate again, we're gonna have a squared e to the power ax. So if you keep differentiating, just keeps going that way. You keep having your a increasing. So let's differentiate. Let's integrate the dv as well. So we're gonna have 1 over b sine bx, right? And then if you do the same thing here, we're gonna have negative 1 over so negative 1 over b squared cos bx. Alright, so the next thing we're going to do, attach sign to it. So it's plus, negative, plus, as plus minus plus, and if you have more terms, you keep doing plus minus like that. So the reason why I stopped it, because this last term we have here, this guy, if you merge them together, it looks like the question we have. So it's like we have the question back. So that's why it's called recursive integration. So it doesn't really make sense if we keep integrating and we keep differentiating. So the next thing we are going to do is that we are going to merge them diagonally, and then we take the last term together. So this is it. So you take this guy together, and then you match the last one together, and that's it. So let's write that out. So we have our integration, which is our I equal to, so the first one is going to be e to the power of ax over b sine bx, right? Then the next one is going to be this guy. Don't forget the negative sign, they multiply each other, right? So we're going to have plus a over b squared e to the power of ax cos bx. And then the last one, that's this guy, this term together, yeah? So that's that term together. So you're going to take the integral of the last one always. Yeah, you can check my video. I talked about how to use this as well. So a squared over b squared integral ax cos bx dx. So exactly what I said. So this is our I, which is the question itself. So all I have to do is just replace it with that, and then take it to the other side. So we have, if you take this one to the other side, so we take it to the other side, yeah. So we're gonna have I. Let me use something else. So we're gonna have I plus a squared over b squared I equal to ax over b sine bx plus a over b squared cos bx, right? We're gonna have that. So you can just do the SCM of this guy, take the SCM. So with that, we're gonna have x squared plus b squared over b squared, yeah. So we take the SCM of this, so b squared, and then you multiply 1 in b squared is b squared, and then is b squared and b squared is 1, so you're gonna have that equal to eax over b sine bx plus abx squared ab squared ex cos bx. So I think it should be e to the ax here, somewhere here. Yeah, that's it. So that's a mistake there. So now we can have our integral I, which is what we need to be b squared. So we divide both sides by this term here. Yeah. So it's gonna be this. Yeah, sine. So we're just kind of like repeating that, writing it again. Yeah, and that looks exactly like the answer we have if you definitely simplify. So let's just go ahead and simplify that. So on simplifying, I have I equal to 1 over a squared b squared. So this is going to be b to the power of ax sine bx plus a to the power of ax cos bx. Yeah, and that's it. Yeah, I know it's very simple. Yeah, it's very simple, and that's why we're using this method. It's tabular method. It's quite simple. Unlike the other one, it's long and stressful, but if you know how to use it, it's going to save you a lot of stress and a lot of time. So I believe you enjoyed this video. Kindly like, share, and then ensure that you subscribe. Thank you guys. Bye for now. See you on the next one. Cheers.